Hello everyone, and welcome back to our IB Physics tutorial series. Let's take a look at these SUVAT equations. So the name SUVAT actually comes from all the variables that these equations have. So we have S, U, V, and T. And let me just quickly go through what each of this letter represents. So S stands for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. So these variables are key players when it comes to describing motion using these equations. So once we know what S, U, V, A, and T stands for in these equations, we can actually start applying these equations to some real-life IB physics questions. Now before that, it is important to note that SUVAT equations actually have certain conditions for their application. This means that if these conditions are not met, we cannot use SUVAT equations to model the motion. So SUVAT equations are only valid under the assumption of constant acceleration. This means, in other words, that the acceleration experienced by the object remains throughout the motion that we are modeling. So an example of this is perhaps a projectile motion question. Acceleration is constant throughout the entire motion, as we know that the acceleration due to gravity, or g, is constant throughout the entire question at 9.81. This means that we can actually use SUVAT equations to solve such questions. So now we have a bit of understanding about SUVAT equations. Let's try to apply them to an actual problem through a very simple question. So to begin, let's imagine that we have a car. And this car is at rest. That means it's not moving. Suddenly, at time equals 0, the car accelerates at a rate of 4 meters per second squared. And this acceleration continues for 10 seconds straight. Now this acceleration is given to be uniform and constant throughout this entire 10 seconds. It ensures that we can use SUVAT equations because acceleration is constant. That means we can apply our SUVAT equations. So how do we find the distance traveled? So we know that displacement is equal to S, and we're trying to find this. So the way I approach every single SUVAT equations is firstly to write down all the variables we know or we don't. So it's very easy with SUVAT. The variables are literally SUVAT, S-U-V-A-T. So the final velocity, we do not know. And the initial velocity here is 0. Now we know the initial velocity is 0 because it is given that the car starts at a rest. That means that it stopped moving. Acceleration is given to be 4 and time is 10 seconds. So now we see that we have 2 missing variables and 3 variables that we have. And we have 4 equations to use. We are trying to look for S, which is distance or displacement. And we have the information about the initial velocity, acceleration, and the time of this entire interaction. So let's look at the equations and see which one we can use. So when picking which equation to use, we obviously pick the ones that have these 4 variables. So we have S, U, A, and T. So if we look at the first one, which is S is equal to UT. Now you can find all of this in your data booklet, so there's no need to memorize SUVAT equations. Looking at the first equation, we have S equals UT plus half AT squared. Now we have purposefully picked an equation that does not contain the variable V. If you look at equations 2, 3, and 4, they all contain the variable V. And because V is unknown, we cannot use them. So let's plug everything in. We're trying to find S, so it's fine that we leave S as it is. We know that U equals 0, so this entire variable is out. And we're left with half A, which is 4, times time squared, which is 100. That means the total distance traveled is 200 meters. And that's it for SUVAT equations. Remember that practice makes perfect, and you can practice SUVAT equations in our Topic 2 question bank. Our question bank comes fully equipped with interactive mark schemes as well as video solutions. Click on the link in the description to get started for free. I hope you found this video helpful and good luck with your IB Physics journey.